Well, hi there and welcome at a new screencast on TypeScript design patterns. And in this screencast, we'll be discussing the iterative pattern. When we look at the definition, it states that it provides a way to access the elements of an aggregate object sequentially without exposing its underlying representation. So let's have a look at the Uml class diagram, where we see we have a client, and the client has a aggregate object which it would like to go through all objects. So sometimes you have, for example, a tree view or a list, and instead of knowing anything about the list or the hierarchy or anything like that, we would just like to go through all objects of that object, that aggregate. So in the Uml class diagram, we see that we have an aggregate, which is an abstract class, and we have a concrete aggregate, which implements this aggregate abstract. So this interface has a method called createIterator, and the iterator will then return a iterator interface. And the iterator interface is very simple. It has a first, next is done, and current item. In TypeScript, I created a little bit of a different way to implement this pattern. Nevertheless, I did create a way to indeed go through all objects of an aggregate. So let's have a look at the code. Head over to Visual Studio, and what we see here is that I first define an interface. And the interface states that I expect the object that implements this interface as an indexed property which returns a specific object. And the object is of type T in this case. And we also state that this IEnumerable must have a length object. What is nice about TypeScript is that objects don't really have to state that they implement the interface. What TypeScript does is that it verifies if an object has all the methods that are defined in the interface, and if so, TypeScript allows you to use that object as the interface. So we can now use this IEnumerable interface on, for example, an array list or on an array or on a node list, because both node list and array have indeed a indexer, which returns an object from the array or node list, and also have a length property. So then let's have a look at how the enumerator actually is constructed. So what it does in this case, instead of extending or decorating node lists and arrays with a getIterator, I created a separate class called enumerator of type T, which in its constructor has gets the items passed. Okay, so this is more of a wrapper pattern. So what I do over here, we pass an object which implements IEnumerable of T, the interface we've discussed before, and then on this method we have a reset, move next, and current method. So I didn't completely follow the Uml class diagram. What I did over here is that I implemented the same methods as are there available in the .NET framework. And in this way, we allow .NET developers to easily use our iterative pattern. So with this available, let's see how you can use that. So let's open up the load method of our window. What I have here, I have an array which has 4 string values: Wesley, Norbert, Sam, and Sridhar. And we also have a nodes list, and we get that by just document get elements by tag name h2. So this will return all nodes with a tag name h2, so the headers. So what we can then do with this array and this node list, we create a new enumerator. So var enumerator is new enumerator, and first of all we pass in the persons. And what is nice about this interface, that while most of the times in JavaScript when you iterate through items, you define a variable I, which has a value of null, and as long as it's smaller than the length of the list or array, we add one to the variable I, and in that way we fetch items one by one. With the enumerator pattern, we can now easily use while enumerator move next. We get the current, and in this case we log it to the output. So there's no difference in how we enumerate through the array or the nodes list, because when we look at the second part of our code here, we just create a new enumerator with nodes list, and while nodes enumerator move next, we log the text content in this case. So we call nodes enumerator.current.text context, which we log to the output. So let's head over to the page again. So how does this work? Let's go down. Here we are. So we have a persons array and we enumerate through that. So we have iterating through the array, Wesley, Norbert, Sam, and Sridhar. And then we are iterating through the nodes list. And we have definition, Uml Class Diagram, TypeScript code, and output. And that is how you can use the iterator pattern.